Well, welcome everyone to this week's Industry Hour. My name is Kelly Stutz. I'm one of the SOE Hub advisors. And tonight we are featuring biomedical engineering. We have 2 alumni and 1 current student to talk about their experience as a biomedical engineer, any advice that they can provide, and just their overall experience at RPI and beyond in some cases. So we want to let everyone know that this will be provided via YouTube and recorded. So if you have any questions, please put them in the chat and we can get to them at the end. With that, I'm going to share my screen and get to our presentation. Kim, are we good? Oh, of course you turned the camera off.
Yes, we're good.
Okay. All right, thanks. All right. Cool. So tonight we are featuring biomedical engineering. It's one of our more popular majors at RPI. I am the SOE Hub advisor for biomedical engineering. So if you're interested in this major, you have more questions after this session, please reach out to me or make an appointment with me. I'll gladly answer those questions. A little bit of our agenda today, we're going to talk about the Center for Career and Professional Development, or the CCPD. I'm going to introduce our panel, and then we'll do a formal interview with a Q&A session. First, the CCPD. We have engineering career counselors. Emily and Kristen work with our students very closely. They help you with your resume structure, potential job opportunities, a lot of resources that come out of this office, help you with your Arch Away experience and those opportunities, what those could look like. So I highly recommend making an appointment with them through the CCPD and just get an idea of what that looks like, especially when you're graduating. That's kind of important for when you're finding a job, but even for your internships and other things are super helpful. So just some services and resources. They have major career exploration. Of course, we could do that, but they have other ideas too, that when it comes to what your goals are. Developing application materials, whether that's for med school or post-grad, they can help you with that as well. Interview prep, applying to grad school, LinkedIn, social media, career fair. I believe the next career fair will be in February. So now's the time to make your appointment and make sure that you're feeling prepared for that event. They have drop-in hours as well, workshops, professional headshots. They also have a clothing closet. So if you feel like you're not really prepared for the in-person career fair yet because of you feel comfortable in what you're wearing, definitely ask them about that as well. You'll make an appointment with them through Handshake. Also through Handshake, you'll find other job opportunities, internships, all for RPI students. And this way you can follow up with them at the career fair as well, if it's a company that you're interested in. These are some of our employment relations for biomedical engineering. Some of these might look super familiar to you. Some of them may not. And they may have a biomedical engineer and maybe it doesn't exactly fit what that job is or what that company is, but engineers are super utilized in all of these areas. So just something to consider when you're looking for internships and job opportunities. We do have some salary statistics from the class of 2022. You'll see biomedical is at the top there in terms of average, but then there's quite a range. So it really depends on what area you want to go into. But just because you start in one salary range, you can always move up in certain areas or go to other job opportunities as well. I'm sure we can hear more about other opportunities that our panelists have as well tonight too. Okay. Told you that would be super quick. I want to make sure that we are cognizant of time, and I want to value our panelists here tonight. So we'll let them introduce themselves. So Mike, let's start with you.
Hey, Kelly, everybody. Kelly, thank you very much for having me on. It's always a pleasure to be able to donate some of my time back to RPI. But without further ado, my name is Mike Arbolita, former RPI alum of class of 2019. Started off right after I graduated at Regeneron as a manufacturing engineer, and then now I'm currently over at Stryker doing some manufacturing engineering for them. And living in downstate New York, a little bit away from RPI, but close to my hometown and close enough to Stryker so I can commute in now that we're back in office. So thank you.
Awesome. Thanks. Alex?
Hi, my name is Alex Katsakis, and I graduated from RPI in 2018 with a Bachelor of Science in Biomedical Engineering. I also had the opportunity to study abroad while I was there at University College London. So if you have any questions about that, I can answer those. I got my master's in mechanical engineering from Boston University, and I'm currently a manufacturing engineer. I worked for a company called Afera Inc., which was a startup, and we were acquired last year by Medtronic. So now I currently work there, and we make heart catheters for atrial fibrillation. So if your heart beats irregular, they use our device to go in and kill the tissue. And I've been living in Boston for 5 years now, but I'm originally from Michigan.
Awesome. And Sam?
Cool. Thank you. My name's Sam Harrington. I am finishing up my undergraduate degree here at RPI this semester, and then I'll be pursuing a graduate degree in biomedical engineering. Previously, I've worked at Medtronic, working in coronary and renal denervation, and also at J&J in their pharmaceutical branch. So I've seen a little bit of industry, and yeah, just looking to keep going with school.
Awesome. All right, I'm going to stop sharing so I can read the questions. All right, Mike and Alex, we'll start with you. What made you decide to be a biomedical engineer?
For me, it was pretty simple. I think probably like a majority of the attendees here, you typically have like a good knack for math and science. So that was definitely true with me. That was principally the subjects I was good at in school. And I also had a uncle who was still a neurosurgeon, and he was really the one who exposed me to a lot of the things that he was doing in the medical field at the time. So some pretty crazy things I would say to expose somebody that's younger, but craniotomies, spinal fixation, trauma, surgeries and things of that nature. And it kind of really molded me. I really thought that I was going to be going to med school at one point until I got to high school and really found that, math and science was more my passion. I really wanted to do something that was a little bit more hands-on. So ended up talking to guidance counselors, trying to see where my career interests could overlap and ended up on biomedical engineering, which was honestly for me the perfect combination of everything. I knew it was going to be really math and science heavy, which is something that I was looking forward to as I took my next step out of high school and into college. And I knew that there was great companies out there that were doing a lot for people that get hurt, get sick, wide variety of diseases and sicknesses out there that definitely need curing. So that was kind of where everything overlapped for me, and I went into RPI knowing that I wanted to be a biomedical engineer.
So similar story to Mike. I always liked experimenting, had a fascination with, the world and how things worked, liked math and science. For me, I knew that I was going to work like for a large portion of my lifetime, spending a lot of time at work. So it was very important to me that my job directly improved people's lives. And I knew from the beginning that I didn't want to be a doctor. I don't like blood. I don't like coughing. So biomedical engineering seemed like the best fit for me.
Awesome. Thank you. And then for Sam, why did you choose biomedical engineering?
Yeah, pretty similar to Alex. I mean, I knew I was going into an engineering field, and the kind of deciding factor for me was I knew if I went into biomedical engineering, I would be working on something that would help people in the long run. So for me, that was worthwhile enough to try and make that my career. So that's why I did it.
Awesome. Any specific things you're going to do in grad school that you have lined up, or do you feel pretty set on the curriculum?
So for me, um, my focus is more data-driven solutions for medical problems. So something I noticed when I went into industry was there are a lot of great devices out there, but they don't necessarily leverage all the information they have. So for me, I figured if I was to learn more to try and, contribute positively to society, that would be my focus in my doctorate.
Cool. Just curious. Thank you. Okay, next question. Mike and Alex, what is the day-to-day function of your position or in the industry in general? And we'll start with Mike.
Yeah, I think there's a wide array of things that, a biomedical engineer does on a day-to-day basis, at least for me right now. It's a lot of continuous improvement, a lot of looking at our current processes that we have in-house for manufacturing, total knee arthroplasty systems or um, hip replacements, shoulder replacements, and looking at how we can improve those so that the product is, higher quality, a little bit more cost effective, and just, overall a better solution for the patient themselves. So, with AI and automation, I think that's a big push that a lot of companies are making right now, not just necessarily in med tech, but pretty much in any industry. Whether it's automation, whether it's aircraft, computer science. So that's definitely something that Stryker is investing heavily in right now. And a lot of our visual inspection systems that we use to make sure that product is, the correct dimensions, is getting marked correctly, is being handled by, automation and AI machine learning systems. So that's actually one of the current projects I'm working on right now, which is, I think, a perfect example of what a biomedical engineer can do once they get out into industry. A little bit of patient solutions, a little bit of programming and AI, and really getting manufacturing to a whole nother level.
So I'm also a manufacturing engineer, but I'll go a little bit on the different side. So one of the main jobs is, helping to make sure that product gets out the door. So, I usually start my day checking emails and any Teams or Slack or chats. I don't know if everyone's familiar with that. Then I'll just check in on the manufacturing floor and make sure there aren't any issues. And then I start working on tasks such as defect investigations or improvement projects and have meetings, and that cycle kind of rotates throughout the day or week, and it depends what's going on. I'm more on the cusp of the pre-market to market, so I'm not really in sustaining, so it's a little bit different. We're not as stable as a site, so we have more issues in the beginning. So most of my day is just trying to make sure that all the operators and assemblers have everything they need to do their job properly.
Cool. Mike, I have one side question. I get asked a lot about prosthetics, and unfortunately, RPI doesn't have a faculty member who specializes in prosthetics.
Yeah.
What do you recommend, or do you necessarily need to specialize in that in terms of what you are doing now?
No, I would say, when you think of prosthetics, people think of, a body part and that you really need to be familiar with, the anatomy and things like that. But, the way I look at it is prosthetics are almost like, manufacturing a replacement car part or, manufacturing a replacement computer part. It's not something that you need to specialize in. I think we actually have a lot of different disciplines here. Whether it's mechanical, whether it's electrical engineers that come in and help us along with our projects. So that's definitely, I think, the bright side of being in medical devices is you'll get to meet a lot of different specialties here that all kind of contribute their own to the project. So it's not like you need to be an expert in prosthetics at all. But if that's something that you're willing to do from the get-go at RPI, then it's definitely the right way to go, and it's definitely going to get you closer to working with shoulder and hips and knees and things like that.
Cool. Thank you. Got to
Absolutely.
clear that up and just let these students know because I get asked a lot. So then they're usually torn between mechanical or biomedical. So we have more conversations, but it's kind of the combo that Alex did. And we'll get there. So next question for Mike and Alex. What job titles and roles are common in industry? We'll start with Mike.
Yeah, so For me, at least, the titles that I work most commonly with are, the lines of validation engineer. So typically the ones that will set up the equipment, make sure that we're proven to our regulatory bodies that the equipment works the way it's intended to work, and that we have a stable process to produce the things that we need to produce. Obviously, manufacturing engineers like myself and Alex, you can definitely get into more of the new product development and new product innovation side of things, where you're kind of working with the bare minimum and you have to come up with a solution for a current problem that's out on the market that might not have a solution yet. And you can even get into in research development, which is something that students can definitely explore at RPI. With undergrad research projects, I'd say that's probably one of the closest things that you can do as a student, is to do some R&D. That'll translate really nicely into R&D here at companies like Stryker or Johnson & Johnson, Medtronic. That's definitely, I think, as bare bones engineering as it gets. You're really looking for cutting edge solutions to problems that exist that don't have solutions yet on the market.
So I work closely with quality engineers, other manufacturing engineers. Ours are called reliability engineers versus validation, but it's the same idea. Medical device industry, you have to validate your processes and your equipment. So there's things called IQ, OQ, PQs, and you change all your settings and you make sure everything's running properly. I work with regulatory people. We just call them regulatory affairs specialists. Work with the clinical team. I think those are the main big ones, but there's a lot of biomed people that go into R&D, manufacturing / ops, or quality engineers.
Cool. Thank you. Okay, next question. Mike and Alex, what is your favorite part of your day as an engineer? Go ahead, Mike.
Tough to say. I think one of the beauties of being an engineer is that you don't really have a set schedule. I mean, that's exciting to me, at least, because I'll come in and something will get thrown my way, and you have to be able to change up your schedule pretty quickly to go address the issue on the floor. But if I had to pick one thing for me right now, it's just being able to work towards finding better solutions to our current manufacturing processes. So the mindset I like to carry as we come into a new workday is that you want to be able to go out there and find a solution that hasn't been found yet, and try to get just better quality products out to our patients. You're really helping these people, whether you realize it or not, and to be able to have just even a small part of that is what makes this job exciting. It's what makes me want to come in every day and get a little bit better and learn some more.
I was really torn when thinking about answering this, about choosing between continuous improvement and defect investigation, but I think I'm going to choose defect investigation. So basically, if something goes wrong with the product or equipment, it's my job to figure out why, and then also come up with a way to fix it. And this is often very hands-on and can be quite challenging, because every day there's a new way for something to break, and it involves a lot of experiments and testing and problem solving, and working with teams, R&D, design, quality. So that's why I like that the most.
That's fair. It's reminding me of like IED or all the group projects that they do together, and
the
finding
car.
a solution. Yes, all of it. All right, Sam, we didn't forget you. Can you tell us your favorite experience you had as an intern, or even some of the other research you've done as a BME?
I really liked working in R&D at Medtronic. I thought it was a really good place to be because they would give me a problem, but they would give me freedom to operate. So in other internships I've had, there's a lot of red tape or things you can't do and whatnot. And they basically said, if you have a good plan, like, we'll back it up, we'll get you the resources you need. And for me, that was super, like, it was just fun to go to work every day and, sort of have my own creative approaches to these different problems. So for me, I think that was probably my favorite experience.
Awesome. Thank you. Okay. Mike and Alex, as a BME, you're required to complete certain tech electives for your degree. Honestly, Sam, you can answer this too. Can you tell us a little bit more about the tech electives you chose and your overall experience in those courses? And we'll start with Mike.
You really tested my memory with the tech electives question, so I had to go back and look in the handbook to see what I had taken. But from what I remember, I took EMD, so elements of mechanical design, biomechanics 2, a little bit of biomedical fluid mechanics, and I think there was biomedical data science as well, which was honestly a very interesting course, and it's kind of actually helped me with a lot of the AI stuff I'm doing right now. But all those courses were excellent. It's a great way to get a little bit more breadth in your experience as an engineer at RPI, and it allowed me to explore different areas of just engineering in general that I don't think I would have been able to explore if the curriculum was a little bit more rigorous and made you choose from within biomechanics, which was my concentration back then.
So I thought that I wanted to do more of the science side of biomedical engineering when I first went in, but then I realized when I joined a research lab freshman year that I really liked like macro things, like touching, seeing what's going on. So I did biomechanics for my concentration, and I also don't remember all the ones that I did because I took 2 of them abroad. But I know I did biomechanics, biomedical fluid mechanics, and thermals and fluids. And actually, thermals and fluids was one of my favorite classes that I took at RPI. I know like a lot of people don't like TF1, but that was one of my favorite classes. I had a great experience in it, and it made a lot of sense.
So for my favorite tech elective I've taken in the BME department, I really liked biomedical data science, but I was also lucky enough to have some time in my schedule to go to the CS department and also take data structures, which I thought was really good for the research I was doing within BME. And so just taking the time and trying to find a course that is going to help, move you forward and not feeling like you're restricted to just biomed classes, I thought was really nice and super helpful in terms of things I've learned.
Thank you. I will say that the concentrations are now optional. Hate to tell you that, but they've kind of expanded it a little bit to be a little more flexible with students. So as long as they have like 1 or 2 in the BME, might be even 3 to double check, they meet those requirements. So any questions about tech electives, students, let me know. Next question. Many students often ask about the type of work engineers do. Specifically, is your position hands-on or more desk-oriented or analytical? Can you tell us what category your work falls into? And this is for Mike and Alex.
I would say right now it's a perfect combination of the two. So there's definitely days where I'll come into the office and it's a lot more behind the desk, doing either, investigation reports, reviewing inspection guide sheets, investigating nonconformances and, what happened during the actual process that went wrong and how we can fix it. To me, those are a little bit of the less exciting days. I'm definitely more of a hands-on person. So when I do get to go out on the floor and work with the ops engineers and quality engineering to come up with a solution and get my hands a little dirty per se, those are definitely some more of the exciting days for me. So I think in manufacturing, you get a balance of both. And I think the desk work and the analytical stuff is what ends up making you a better engineer so that you can go out and get your hands dirty a little bit more effectively, on a day-to-day.
Yeah, completely agree with Mike. I have the same experience. I have days that are all basically hands-on days, and then maybe the next day I have to write about everything I did the day before. And it really just depends on what projects, where you're, at on the line, if you're trying to validate something new, and then where along that process you are. But I think that's the nice part about manufacturing is that you do get both of those experiences in your job, and no day is ever boring. So
That's true. Just like class. I'm trying to relate it. All right, next question. This is for all of you. What did or does your undergrad experience look like? Did you do internships, join professional groups, undergrad research, or other extracurriculars? Can you make any recommendations of organizations or clubs to our current students? And we'll start with Mike.
Yeah, I guess my experience might be a little bit different. So I definitely did internships. I definitely did research. Most of my time was taken up with baseball at RPI for the 4 years I was there. So a lot of early mornings, a lot of late nights, but I would say that I had a really good, range of experiences. So, with regards to internships, I was able to intern at Regeneron for 2 years, as well as down in Wake Forest, Center for Injury Biomechanics, where I did a little bit of research and development for them as well. And then I also did undergrad research, like I had mentioned before. So I was very fortunate that as an undergrad, I found the musculoskeletal mechanics lab with former professor Dr. Eric Ledet, who was a great mentor to me. And like I said before, I think doing research as an undergrad is a great experience because it'll give you basically a little insight into different types of projects that are going on in the world of biomedical engineering. It's not all just medical devices. There's pharma, there's different types of machine learning going on, AI, programming. So I think undergrad research is something that any student can benefit from. I highly recommend you go and talk to your professors after class and see if there's a project they're looking to bring, some undergrads onto that you can maybe help out with. And I would definitely say that even if you're not an athlete, there's a ton of club sports at RPI that I know are always looking for new members. So it's a great way to go out and meet new students, network a little bit, and you never know, those same students might be the ones that end up in your class. So you guys can form a little group and get to all the assignments and homeworks and succeed together. So just a great way to get the full RPI experience, I would say.
So I did an internship at Shire, which is a pharmaceutical company, actually. And then I also did one at Clover Biomedical, which isn't a company anymore. They all went to a new company, but it was a consulting company. And then I worked at Medtronic for a summer at a different location than the one I'm at now. And then I performed undergraduate research in a lab, and this was more science-based. So I was looking for a biomarker for osteoarthritis. And then I was in the Society of Women Engineers. I still am. So if you move to Boston, you can join that chapter. The Biomedical Engineering Society, Tau Beta Pi. I was in AGD, the Women's Mentor Program, and Circle K, which is a volunteering organization, which if you have time, it's a really great club. You get to give back to the surrounding community, and it's just a really great opportunity.
So in terms of my work experiences, I started off in fall of 2021 working at a company called Trump, which makes laser manufacturing devices. So pretty out of the field, but for me, it was more about getting my foot in the door in terms of work experiences. And then the following fall, so I ended up taking 2 fall semesters off to do co-ops. I worked in Philadelphia in pharma for Janssen Pharmaceuticals. And then this past summer, I worked in more med devices with Medtronic. So one of the things that helped me get to the sort of jobs I wanted to be in was having undergraduate research on my resume. Because a lot of the times in interviews and stuff, people would ask me like, name a project you worked on for a long time or whatnot, or something of that nature. And it's really helpful to say, I've been working on this for almost a year now. Like I've been able to accomplish X, Y, and Z, and it sets you apart a lot from people who are just doing the typical class route. Even if you have a great GPA, it's better to say, I was able to accomplish something tangible because that's what a company is going to want you to do. And then aside from that, I'm in Greek life. So it's been a little bit weird with COVID and whatnot, but now that things are back to normal, it's nice for me to be able to work, a long day and then also be able to hang out with my friends. at night and sort of keep that work-life balance. So for me, it's just been a source of happiness and like trying to keep a good mood throughout, you spend a lot of time working at RPI. And then also it's nice because generationally you have all these people that have graduated and you can just connect with them on the simple fact that you lived in the same house at some point. So it's also helped me with networking and whatnot. So yeah.
Cool. Thank you. Okay, next question. Very often, students ask if the courses that are required for their major are used in the workplace as an engineer or in an internship position. Do you find that to be true? If so, can you elaborate on the specifics? Go ahead, Mike.
It's a great question. It's something that I definitely wondered when I was undergrad. I was struggling through, multivariable calculus and differential equations and all those fun courses if I was ever going to use this. And, to some extent, you definitely do. On a daily basis, I'll see concepts from, statics, dynamics, fluid mechanics, things like that pop up into my work. And it's actually the problem solving skills I think that are arguably more important because it allow you to take a look at a system or a piece of equipment or even just product and say, is the solution viable? Is it going to work? Is it not going to work? Do we even pursue what we're doing here right now? So um, I'd say yes, the concepts that you learn as an undergrad are super important. They're definitely going to pop up from time to time. But I think arguably the way you approach those problems and how you solve them, that mindset is what's going to make you a really good engineer so that you can apply those solutions effectively.
So I use statistics often in my job. So I think that's the one that shows up probably the most directly. And then as well as mechanical and basic engineering principles, especially for defect investigation. So when I look at something and I say, okay, how might this have failed? It's important for me to understand how things work, kind of how things flow together. So I have an idea of where to start, and then it just helps me be more successful. I think going off the problem solving, I think the biggest thing RPI taught me was how to learn and how to learn very quickly. And this sets you apart from your industry peers because employers know you're not going to know everything on the job, but they want someone where they can, give you a problem or give you a task and you can kind of just figure it out on your own with maybe some basic help. And I think that's something that is really, really helpful skill to have.
For me, I think the BME capstone class as a whole is what really elevates you as an engineer because over the course of 2 semesters, you're tasked with taking a problem and with a group of several other engineers actually going through the steps that you would do if you were trying to get FDA approval, documenting all of your work, drawing down all of your sketches, trying to come up with a cheap or innovative solution that you could actually go and prototype and then prove to everyone else that your idea works and is better than other solutions that exist. So when you actually go into the workforce, you sort of have that mindset of, I can't just jump into something. I can't just start doing things without actually looking at what exists because then you're going to run into IP issues and all these other sorts of things when you could have spent your time actually writing down your product specifications. Like what sort of things you actually need to outline in order to bring something into reality. So for me, that was super eye-opening, and it was really the culmination of all those other classes that I had taken, and the application of it I thought was really helpful in my last internship.
Overall, it sounds like maybe humanities or communication skills are also super valuable. I know our students are STEM students, so sometimes it's not the most exciting class, but I will just plug some of our Haas courses and writing intensive courses are important. Of course, I have the panelists say that more, but just something I want to emphasize. I've also heard in past panelists ethics and engineering ethics. We do offer that class as well, so just something to consider. when you're thinking of future classes? Okay, next question. What was one course that you struggled in at Rensselaer? What tactics or resources did you use to succeed in the class? Go ahead, Mike.
Yeah, this one's pretty easy for me. So I particularly remember coming in as a freshman, and I believe Physics 2 was the first class that I took first semester. And I walked in pretty confident, thinking that I was just going to be able to breeze through it and use the same study skills that I used in high school to get through exams and labs. And showed up to the first midterm, handed in my exam, and immediately went to Lally School Management to see if I could transfer, if it was too late to transfer over, because I felt like I got whooped on that exam. Um, and it was a great learning experience. It taught me a lot of things, and a lot of things that I carry still to this day. So um, the most important thing is it taught me how to study and use, the ALAC, use TA office hours, use the professor office hours. I started going pretty much every week, not just for Physics 2, but pretty much every class to get ahead of the curve a little bit. And it was great because oftentimes what students will do is that they'll only show up for office hours when the exam is about a week away, and there'll be lines outside of the door, trying to get questions answered. So the earlier you show up, oftentimes you're the only one in there, and what better way to get ready for the exam and topics that you don't understand with the professor who's actually writing the exam for you. So definitely just showing up to office hours and making the most use out of my professor's time was one tactic that I used to get ahead of the curve and make sure that I was studying more effectively, focusing on things that need a little bit more repetition, maybe things that I didn't get in class as well. I could find some problems in the textbooks and get some repetition in.
So the hardest class for me was definitely modeling of biomedical systems. A lot of people don't find it to be that hard. I found it to be very difficult. I think it's because it's mostly math based, and it just, I don't know, just didn't click for me. So I did as many practice problems as I could. And then again, I want to emphasize, like Mike did, office hours, they are your best friend. They're also great for forming relationships with your professors. If you want to go to grad school, you need letters of recommendation, or you might find out that they have research that you're also interested in doing, and then you can try to get into their lab. But I think practicing, don't just read the text, but doing as many practice problems as you can. I think going to office hours are the best ways to learn for tests and just in general.
So for me, the hardest class was bio transport phenomena. It's kind of like you might hear some mechanical engineers complain about thermo. It's kind of like that. For me, it was a bit tricky because there was a lot of just definitions after definitions with tons of variables and not a lot of application of the problem. So for me, I never really saw like how to use it in practice. So the thing that I have been doing to prepare for tests and like learn material is going through back work and looking at historically like what kind of problems have been presented on the tests, because so especially if you can get um, the professor who's actually teaching the course, because every professor has a different style. They like to hone in on, maybe there's different corner cases or things like that that they're trying to teach you about. So for me to actually go through those problems, like look at all the steps, see, where was I messing up? Why was I messing up? And then practicing a lot of that helped me get through that class.
Awesome. Thank you. There's a lot of tests this week too, so hopefully some of our students can take some of the advice. Next question. Based on your experience, are there course electives like econ, computer programming, management, or writing that would help strengthen markability as a BME graduate seeking employment?
I'm also gonna plug in the humanities here. So during my time at RPI, I was doing a little bit of economics and some technical writing courses that really helped me, and I know definitely helped me to this day, just because writing investigation reports, they have to be as concise and clear as possible. A lot of these reports end up getting either pulled into audits in some way, shape, or form. So you need to make sure that you're getting your point across as clearly as possible. Some other courses, I mean, that are maybe more related to engineering, I would say having a good foundation in some finite element analysis or computational fluid dynamics, or even just being able to design things on, SolidWorks or NX or Creo, whatever your software choice might be, is something that's always good to have under your belt. It's at least in my job, a lot of technical interpretation with drawings, with being able to apply those drawings to come up with, different fixtures, different brackets, things like that. So there's definitely some real world application out there, and the more of the technical writing stuff that you can get in, the more of like the modeling and computer soft skills that you can get in to your daily kind of classes, I think is awesome. And it's definitely going to help you, I think, build a pretty solid foundation as you transition into the engineering, world and different companies.
So another important part about the technical writing is if you choose to work in the industry at a corporation, a company, you're going to have to interact with people who aren't engineers as well. So you might have to buy a bunch of equipment and you need to convince the finance person to sign your purchase order. So having those skills to be able to communicate and convey your point in non-technical jargon is really important as well. One class that I didn't take that I wish I took, and I know both Mike and Sam talked about this earlier, is computer programming. I think we're moving more and more towards that. I see it coming in my industry. I'm sure it's coming in engineering industries across the board. So understanding that and having that has a leg up. And then just trying to be diverse. College is also a time to explore, see what you're interested in. So if you're interested in a course and it fits in your schedule, now's the perfect time to try to do it.
Yeah, I mentioned it earlier, but data structures was definitely super helpful. I think RPI is a really good CS program, and they can teach you a lot of stuff in just one class. It's not easy, but it's worthwhile. And then I agree with Mike. Another great class is IFE. It's one I'm taking right now, and I saw a lot when I was working in Medtronic of people they would prefer to run simulations as opposed to doing mechanical testing, which you can imagine it's cheaper to just run something on your computer and get kind of like a baseline of what would damage look like, and then you can use that to iterate on your prototypes and whatnot. So I went back to RPI and I started taking this class, and it's been really helpful. Just learning how to apply some of the tools in NX to run some simulations on some basic structures. So that was good.
Yeah, I think even a lot of the majors now have created a programming class specializing in their major. So I'm not sure when the programming for BME course started, because it's now a 3-credit course instead of the 1-credit computer programming course they used to offer. I think chemicals do something similar. So they're all kind of creating their own version. Sam, do you remember your experience in programming? Could you share a little bit about that?
Yes, I was actually in the first BME programming class, which was in 2020. So that was created by Dr. Kruger and Professor. It was 2 professors that made it. And so the idea was they had a previous class that was basically just MATLAB, and they wanted to teach us some more C++, because it's such a better language, but obviously harder to understand. So I don't know where it's at now. I know, according to my friends that took it in later semesters, it got a lot harder. So they're basically just trying to teach you the basics. It's more like matrix math embedded with coding. So you get some practice with moving numbers around, and that sort of headspace with like for loops and if statements and whatnot.
Cool, thank you. We always warn students about that class now too. So you got lucky being in the first round. Before I forget, Alex, I want you to share a little bit about your study abroad experience. We get a lot of questions about study abroad and what that looks like, the transfer credit. You mentioned you've done some tech electives abroad. So can you tell us about that process and what your experience was like?
Yeah, so study abroad was one of the best things I ever did. I had a great time. It was really cool to see, how things are taught in another country. And I know like London's obviously not that different from here, but it was also interesting to see like they were complaining about tuition, they're complaining about, not enough textbooks are too high, whatever. And then it was also interesting to see they essentially have a completely different way of learning. So they don't have really tests or homework throughout the semester, and they just have a final at the end of the year. So it's a very different way of studying and learning. I actually started preparing freshman year for this. I knew I wanted to study abroad. If you really want to, I suggest trying to map out your courses now, because you have to get, at least when I was there, you had to get them all approved. So you had to say, okay, this class is equal to this class. If I take it over here, then you had to go to all your professors. So I went spring of my junior year. So I just looked at trying to make it as easy as I can to transfer credits. And by that, I mean, if I already had one that I got approved, so like you could use any of the ones that I already got approved as yours. Did that make sense? I don't know if that sentence made sense, but there used to be a list of pre-approved classes that you could say that students before did. So if you have the opportunity to do it, definitely do it. I learned a lot. I met a lot of people I'm still friends with, and it was just a really, really cool experience overall.
That's awesome. I feel like I've already seen a few 4-year plans come through already with some freshmen talking about their study abroad opportunity. You might have heard about this Arch Away situation now. I don't know what year that started, but I think they're going to incorporate study abroad in that soon as an option. So I'm hoping students really utilize it. But I think study abroad is so underutilized because of the effort of the transfer equivalencies. So that's always a big challenge, but I'm happy to know that even some BME tech electives are possible.
Yeah. So I actually didn't have a chance to utilize anybody's, and I had to get all 4 approved on my own. And I also suggest getting more approved. So I got like maybe 8. Because you don't know necessarily when you get over there if they're going to let you into each one. But so you can do it. It's possible.
Awesome. Yeah, I'm helping my students as best I can, but it is a lot of work on the front end. I think they have to get at least 20 credits or more approved before they even go. So I think there is a seminar or webinar for that soon to my attendees, but we'll be sending that out too once we get that. Thank you. Let's go to the next question. Okay. Have any of you pursued a minor or specialization? If so, can you tell us about that? Go ahead, Mike.
Yeah. So for about, I want to say about 4 or 5 semesters, I was actually pursuing my minor in economics and got to, I think the last class that was required, I think it was a total of 20 credits, and found out that I think I only needed 32 to turn it into a dual major. So that's what I ended up doing. I ended up turning my economics minor into a dual major. So it was a great experience. I got definitely a different perspective on just academics in general, and a different perspective on the world around us. So, I think when you're an engineer and you're in the School of Engineering, I think you're surrounded by engineers all the time. You're all kind of taking the same classes. So it's easy to get stuck in kind of one perspective, and being able to go and take classes in, with the economics professors out there really helped a lot. And actually, some of the ways that you think about problems and modeling and economics applied really nicely into some of my more math intensive and math oriented classes, engineering. So that was my experience with humanities.
I got a minor in management. No specific reason. I just thought it would be interesting to learn more the business side of things because I knew I wanted to work in a company versus, get my PhD or work in a college or a lab. Um, and I knew I might want to go back and get my MBA eventually. So I was just kind of dipping my toe in the water. But I think it helps a lot for large projects. So, in school you have capstone and you have IED, but you don't, unless you do research, you don't really have long-term projects. But I've worked on projects here that are in my company that are, a year long. So it kind of helps manage those things, I would say.
Yeah, I didn't pursue another major or anything, but going off of the Haas pathway, I did do an economics minor just because it was like maybe 1 or 2 classes extra, and I figured, why not explore some of these higher level classes to see if it's something I'm interested in. So it was nice to see like, what kind of work do other majors do. I mean, I took game theory, which for me, I like to play poker, so it's applicable to things I do in my daily life, and maybe there's something in the future that'll also hold true, but I thought it was cool to see a different perspective.
That's awesome. Yeah, I think the Haas minor is the most popular. But then the next one would be management, which to our students, management is not Haas. Those are or courses that would be additional or count as your free electives. But in Haas, you could easily get a minor within the requirements. So it's something that we encourage. So definitely ask your advisor about that or ask me, and we can help you with that. Okay. Do you recommend a master's degree in BME or other postgraduate degrees?
What you end up getting your post grad degree, I think, is a personal decision. For me, it was pretty easy. I picked mechanical engineering just because I wanted to broaden up my field of view a little bit with regards to the project I was working on. So I was doing a lot of R&D at the time that I was applying to do the co-term program at RPI. And so I figured getting more of a mechanical engineering background would definitely open up that field for me as I made the transition from RPI out to, Regeneron and Stryker. So it's definitely served me really well as a manufacturing engineer. I feel like I'm able to be a more effective member of a lot of the projects that are going on here, and um, I was able to really participate in some projects here at Stryker that maybe if I was just a BME, I wouldn't have been able to get my hands on. And just having that breadth of experience with some of the classes from School of Mechanical Aerospace and Nuclear Engineering has been really helpful. And you really get into some pretty high level and advanced concepts that I think are applicable to any sort of engineer. So I would highly recommend. I think it's great for marketability. I think it's only just going to make you more competitive as you go out there and apply to different positions and different jobs that you want to get into.
I think it really depends what you want to do with your career. If you see yourself moving up more of the business side or the engineering side, do you want to be the technical subject matter expert on, this specific material or project, or do you want to kind of be the director of the whole knee surgery group? I knew for me, like I wasn't ready to go into the workforce, and so that's why I got my master's. But I also know people that go work and then they'll take classes. Some companies will actually pay for your master's degree or partially cover it. So I know people who do that as well. I think you can do like a dual BME undergrad and then BME masters. But I do think if you switch, so if you do like BME and then IME or BME and then ME, it does give you more breadth as Mike was talking about. I think if you do a postdoc, it doesn't matter as much because you're spending way more time on something and you're researching something in depth. but yeah, I think that's my thoughts on that.
For me, at least the reason I chose it is because I felt I had a pretty definitive path towards what I wanted. And I felt like a graduate degree would be my path to get there. But for a while, I was not considering doing a graduate degree. I was pretty much honed in on just going into industry. For me, the thing that kind of changed that is when I was in my internships, I felt like I still had more that I could take away from school before I would be, I guess, optimized or like just better at working. And I would be in a position where I would be able to lead people instead of being, more at the bottom and trying to work myself up, which I think is a good thing to do if you're sort of uncertain on what it is that you really like. Because working gives you tons of different opportunities. But for me, because I figured out what it is I wanted to do, I felt, just keep going with school while I have the energy.
Yeah, all that's super good advice. I hear the BME to BME or BME Becky combo a lot. So I'm happy we have a lot of that representation tonight because usually students are stuck between the two. Um, there's not a minor in Becky and there's not a minor in biomedical, so it's pretty much a straight path, and then they kind of find their niche. So we always recommend co-term or whether it's not at RPI or not, some type of master's program can always help. So um, to our attendees, it's just a little plug. We talk about that too. So I realize that my last few questions are very similar, so I think I'm just gonna wrap them all up into one question. Um, so to our panelists, what additional advice do you have for our students, and what do you wish you knew as a first-year college student that you do now?
Yeah, I think I'm going to take a little bit of a different approach here and a different response than some people might be expecting. If I had to go back and talk to a freshman me, a few years back, I'd say really three things to keep an eye out for. So number one, definitely take care of yourself. School is going to get tough. There's going to be some moments where you have a lot coming your way, and it feels like the stress might be getting to you a little bit. But make sure you're taking care of yourself. Eating right, sleeping well, things like that are only going to make you better off as you go through your studies and as things come your way. Number two, you're going to fail, and you're going to fail a lot, and it's expected of you. If you're at RPI, it's because people expect a lot of you, and the classes are going to be tough, and they're going to push you, and they're going to break you down. And like Alex had said before, it's really a way to get you to learn better, to come up with novel solutions. It's kind of molding you into becoming a better engineer. And so don't be afraid of failing. I think everybody on this panel has probably failed quite a bit at RPI, and it's the way you learn. It's the way I learned. It's the way that I made sure that the next time I saw a problem, I was ready for it. So don't let that stop you from reaching, whatever career path or whatever dream job you want to have as you move forward through your studies. And number three, I would just say is have fun and make sure that you get everything you can out of RPI. It's an expensive school, and um, it's more than just the classes. You're going to meet some incredible people there. There's some incredible clubs, activities, Greek life. So try and make the most out of it. And I think that kind of circles back to just taking care of yourself. It's not has to be all work hard and no, play. You can work hard and play hard and get the most out of RPI. So that's definitely something that I would tell myself if I could go back.
So I went into RPI thinking that I wanted to do science, as I mentioned before, and then I thought I learned I want to do more engineering, and then I was like, okay, I want to work in R&D, and then I had an internship in manufacturing, and I was like, this is the best thing ever. I'm gonna do this. So I think like definitely be open to all experiences and change. You can, have a career path and you want to follow it, but if you find something else you like or you say, "Oh, I might be interested in that," definitely explore that. And then throughout the panel, we talked about you have to do all these classes and you need to do research and extracurriculars. And going off what Mike said, that's true. It's important to work hard, but college is also a time to, explore, make friends, make lasting connections. And so just make sure you find that work-life balance, because there were definitely semesters that I personally burned out. And so if you need help, don't be afraid to ask for it. There's a lot of really good resources on campus. And so definitely utilize those, because you're supposed to be learning and growing, but you want it to be in a healthy way.
For me, it's also kind of that relationship things, but it's more with like getting to know your professors on a personal level, because they're very insightful people and they are incredibly busy. But if you take the time to figure out, when are their office hours, like when are they actually dedicating time to undergraduates, you can get to know them well, and like it helps you a lot in things you wouldn't expect. So for me, I was able to ask my professors like, hey, like, how much do you realistically think, like, how hard do you think this class is gonna be? Like, is this gonna burden my schedule? And they'll either tell me, yeah, like, this professor is kind of easy, he's just gonna give you an A, or the other one's gonna be like, yeah, realistically, you're gonna spend like 15 hours a week on this class if you want a good grade. So, like that's super helpful when you're building your schedules, to try and balance it out from semester to semester. And, aside from that, I mean, these are people that can say, hey, like you mentioned you're interested in this. Well, I heard my colleague over here is doing blah, blah, blah. And, those kind of connections will really help push you forward, in your undergraduate experience, both professionally and as well as developing yourself as an engineer, because you're going to get an industry, and one of the things that's a very powerful tool is going up to people that are much more experienced to you and having those conversations and picking their brain and trying to see, what kind of knowledge do they have that's going to be useful to me. And all of your professors have knowledge that's useful to you, so I would go back and do that at a much earlier date than when I previously did.
Wow, really good advice. I really appreciate you all. I don't see any questions in the chat, so um, any last minute questions? Students want to write them in? It's okay. They know where I am. Well, truly, I appreciate all of your time today. This has been awesome. BME is probably our second biggest major, especially last year and this year. They accepted a very large class. So, and we have a lot of undeclared students too who were definitely pushed to this presentation, that are thinking of declaring biomedical or probably mechanical. Those are the two they always are torn with, but also our two most popular. So I hope this can give you all some guidance, and maybe we can get all of your contacts too. If a student wants to reach out, I'll let you know. But I really appreciate your time today. I'm going to end the recording now, and I hope everyone has a wonderful night.
Yeah, I was going to say also feel free to add me on LinkedIn. Yeah.
Cool.
Thanks, everyone.
Thanks, Alex.
Thanks, everybody.
Bye.
Take care.